So during the Chapter 2 practice test, or Level 2, since we're calling those levels now, I should probably change those on here. I'm just going to go through how I want you to kind of think about this. Hopefully you can use this to check your answers as we prepare for the Level 2 test. So, determine if something is a function or not. For something to be a function, for every x, there is exactly one y. That's the definition, right? We can also use the vertical line test if we don't know, if we can't see what the relation is. Okay, so for a, 2 goes to a, 3 goes to a, 4 goes to a. Because every x goes to 1y, we have a function. Uh, that's the reason why. For every x, there's exactly one y. So b, 1 to 3, 1 to 4, 1 to 5. Not a function because 1 goes to I would say because 1 goes to more than one y value. For c, if I graph this, I look something like that. This passes the vertical line test. So this is a function. And for d, we can graph the same. It's going to look something like that. And so we see this fails the vertical line test, so not a function. So then 2, I'm asking you, draw me a graph that is not a function. Explain why. Your answer can vary for this. I think the easiest one is like a sideways parabola. And this fails the vertical line test. If we know that, then we're pretty solid on what makes a graph a function or not. So for 3, state the domain of each function. The domain for any polynomial is all reals. We have no restrictions. For b, this is a fraction. And what we don't want in a fraction is we don't want it to be equal to 0 on the bottom. So what number makes the denominator 0 is 0. So in this case, x can't equal 0. For c, we have a fraction and a square root. Now normally we don't want square roots to be negative, so we will take whatever's underneath the square root sign and make that greater than or equal to 0. But we also know that we're in the denominator, so instead of writing greater than or equal to, we're just going to write greater than, because if I was equal to 0, then I would be undefined. So simplifying this, I'm just going to add 2 to the other side. So that's x is greater than 2. And that's my domain for each one of these. And notice, the domain, we mean the x values. All right, 4, combine these together. So f times g of x just means 3x plus 1 times x. And to simplify that, we can just distribute the x, so we get 3x squared plus x. That's the product of those two functions. The second one, add these two functions together. So I have 3x plus 1 plus x, which is 4x plus 1. And then c is asking, well, what's f of g plus 3? So we already found what f of g is, so we're just going to plug in 3. So that's going to be 4 times 3 plus 1, which is 12 plus 1, which is 13. All right, let's flip it over and work on a couple more. So question 5 has got quite a long list, and we're all going to reference this graph for them. So find f of 4. Well, what's the y value when x is 4? So I go over 1, 2, 3, 4, and I see that my y value is 0. So that's equal to 0. What's f of negative 3? Likewise, I go to negative 3, and I see that that's at 1, 2, 3, 4. So f of negative 3 is 4. That's my output. Is f of 1 positive or negative? So at f of 1, I see that it's a negative 1, so that's negative. For what values of x is f of x 0? So this question's saying, where are my x-intercepts? So I'm going to look. It looks like I'm at 1/2, comma 0. Or what? So it's asking what values. So I'm going to write 1/2 and 2, 3, 4, and 4. So these are the x values that make f of x equal to 0. What are the x values that the f of x is less than 0? So that's saying where is y negative? Now here I see that I have two spots. So where is x less than 0 and not equal to? So I would say from 1/2 to 2, union 2, 3, 4 to infinity. So looking at part F, what is the domain? What's the farthest left I can be? Which I can see as I keep going off, so negative infinity. What's the farthest right I can be? Positive infinity, so there's no restrictions. So we can write all reals. Or we could write this bold R. What is the range? So we look at what's the lowest I can be, which looks like -4, and what's the highest I can be, which is +4. So the range would be -4 to 4 with brackets. The other way you could write that is -4 is less than or equal to y, which is less than or equal to 4. I personally think that interval notation is a little easier to read, and that's why I use it. H. What are the x-intercepts? If I'm asking you for x-intercepts, I want ordered pairs. Okay, so I look at the x-intercepts, and it's kind of like what we already answered for D. So it's going to be 1/2, comma 0, and 4, comma 0. What are the y-intercepts? Well, I look at my graph here, and it's 0, comma 1. For my local maximums, so my local max, I see that I have 1 right here at 3, comma 2. At -1, 4, and 4, at -1, 4, we don't really have a change in direction, so we can't say that this point is a maximum. Likewise, for a local min, it looks like it's at 1, -1. And again, we can't say that this line is a minimum because a minimum is a change of direction. So that takes care of number 5. Number 6, determine if the function is even, odd, or neither, and show all your work. So in order to figure out if something is even, remember, even f of x is equal to f of -x, which means my original function is the same as if I plug in a negative value. For odd, I'm saying if I plug in a negative value, then it's the same as making the whole thing negative. So these are my tests. So the first one is I'm going to try plugging in f of -x, which is -3, -x squared plus 6. Well, when I square a -x, that just comes out to be positive. So now I look at this, and I look at my original. That's the same thing as f of x. So I can say this is even by this proof. If it wasn't even, then I would test to see if it was odd. So I just make the whole original negative. But I don't have to. I'm done, so I stop. 7. If f of x equals 2x plus 1, find the secant line that goes from x equals 0 to x equals 2. Okay, so secant line, I first need to find average rate of change. And if you remember, that is the difference in the, so it's f of 2 minus f of 0 all over 2 minus 0. So it's kind of like slope. So if you know that it's kind of like slope between 2 points, it should come out to be 2. So let's plug in here. What is f of 2? Well, that's 5. What's f of 0? 1 over 2 minus 0. So that's 4 over 2, which is 2. Okay, now I look at these x values. I already found the y values here. So my ordered pairs that I'm really looking for is 2, 5, and 1, 0, 1. Those are my 2 points. So I can write my equation just by plugging in either one of these points. So I can have y minus 5 equals 2 parentheses x minus 2. That's one of my equations. Or I know that this is my y-intercept, so it's y equals 2x plus 1. If you look at this graphically, here's my original, and I want to draw a secant line. Well, the only way I can draw a secant line is if I draw another line right on top of it that would go through these 2 points. That's the only way. So this question is a little bit redundant. I might switch this up for the test, maybe ask you if like it's 2x squared or 2x cubed to find the secant line. Those are things that become a little more interesting. All right, let's flip it over. We have a couple more problems to finish up with this level practice test. So moving on to problem 8, describe the transformations that are occurring in each. I want you to be able to list out all the ones that are happening. So this negative sign is a flip over the x-axis, and this 1/2 is my vertical compression. If you want a shorter way of writing vertical compression, we also call that a shrink. So it's a vertical shrink, which means it's wider. So here, if I look at y equals negative 3x cubed, I have a flip over the y-axis because that negative is on the inside. And then that 3 is a vertical stretch. We also say that's getting skinnier. And if you want, we can just write a stretch. And really that's stretching it by 3 cubed, which is 27. So that's a really big stretch. Number 9 is a piecewise. We should be well versed in this. If not, there's still plenty of examples in the book that you can do. So let's first start by graphing this, and then we'll find all the information. So we start with my first piece, and I want to be, when I'm left of negative 3, I look like this absolute value. So left of negative 3, let's plug that in. This is an absolute value that's moved to the left 3 up 1. So that's my negative 3. It's an open circle because I can't be negative 3. And then my slope is up 1 over 1. And I'm going off to the left. Next, I look at from negative 3 to 2, I'm this line. So I'm going to plug in negative 3, and I get negative 2. So negative 3, negative 2. That's a filled in circle. If I plug in 2, I get 2 plus 1, which is 3. So 2, 3. That's an open circle because I can't be 2. And then I'm going to draw a line from those 2 points. The third one, I'm x squared when x is greater than or equal to 2. So I plug in 2 into my third one. 2 squared is 4. And then I look like a parabola going off into the distance. So this is my piecewise graph. What is the domain? Well, to the left, I'm everything. I can be negative 3, I can be 2, and I'm off to the right. So the domain here is all reals. I can be any number. If I want to look at my x-intercept is right here. So that's negative 1, 0. My y-intercept is right here. So that's 0, 1. And what is the range? Well, range is low to high. So the lowest I can be is negative 2. And I can be that. So that's negative 2. And then I go up from there, and I can be these values. So I am -2 to 3. And then I include all of these points above that. So -2, the highest point is infinity. So if I write that right, it's bracket -2, comma, infinity. Or y is greater than or equal to -2. And that's the range. One more page, and then we're done with this level practice test. So these last couple, these are sketching graphs based off of transformations. I expect you to know all of the parent functions that I gave you in the notes. I think there's 9 of them, so expect to be able to graph or match each one of those. So let's start with this. Graph an absolute value of x minus 1 plus 3. So that's to the right 1, up 3. And then I know that my shape is a V that goes up 1 over 1 in each direction. So there's my graph. Done. Here, my parent function is an x cubed graph. And likewise, my parent function was a V. All of these start at the origin. That's why we shift from the origin. So this is left and left 3, down 1. So 1, 2, 3, down 1. And then if I'm just doing a basic sketch, I'll look something like that. I can test for where my y-intercept would be, which is 27 minus 1. So my y-intercept is way up there at 26. So that's kind of what my graph looks like. For C, I have a parabola. So normally it would look like a parabola. That is right 2, down 2. So right 2, down 2. And then this negative flips it. And that 1/2 makes it wider. So if I make this wider, and I'm just sketching it, I open down, and I'm a little bit wider. Last one, square root function. Square root function looks like this normally. So now we're moving it to the left 3, and we're flipping it over the x-axis. So left 3, 1, 2, 3. And flipped it over the x-axis, so instead of opening up like this, it's going to go like there. So those are our transformations, and that's kind of the last thing. There's going to be one story problem on the test. So make sure you study those. Make sure you study your parent functions. Make sure you do domain range, increasing, decreasing, positive, negative, all of those fun things that we did throughout these past 2 weeks. All right, good luck studying.